Hello everyone, welcome to the video for chapter 16, which is all about weight and balance. So before we get into how do we calculate weight and balance, I want to start by a discussion about why is weight and balance important. Now Rod of course talks about this a little bit as well, but the biggest thing you need to realize is if you are outside the weight and balance limits for your aircraft, you are a test pilot, right? You are operating in a range where the plane hasn't been proven to fly correctly. So if it's overweight but in balance, will it take off? Eventually, yes. Hopefully, if you have enough runway. Will you overstress the landing gear on landing if you don't have a nice touchdown? Possibly. Will your climb rate be severely reduced? Also quite possible. So there are limited circumstances where you can fly a plane overweight. You know, if you're ferrying it and you're adding extra fuel and parts and such, you can get a special permit for that. But those permits always come with limitations, VFR only and daytime only and all these other things, whatever's safe for that flight. So this doesn't sound like something you want to be doing all the time. Now, when you are flying, if you are flying and you have your CG out of range, that can be much, much worse for you. So if my CG is too far forward, I can get to a situation where I can't pull the nose up, and that can lead to some very bad landings. If I'm in a situation where the CG is too far aft, I can get into a much worse situation where I can't get the nose down. So there have been several accidents where people have stalled the plane and couldn't recover because they were outside of the CG range. In addition to the total weight limit and the CG limits, there are also limits on what you can put in different parts of your plane. There's usually a limit for the baggage area. You can't put more than 100 pounds in a very typical airplane in the baggage area. And there are other reasons for that. It could be a structural limit or, something else. Right? By the way, if you ever fly helicopters, it gets even more complicated because when we talk about airplanes, we care about weight and balance front to back along the longitudinal axis. When you fly helicopters, you have to worry about the other axis, the lateral axis as well, just because of the nature of those aircraft. So what I have here is the Cessna 172S manual. We used this in a previous video. And it's the weight and balance section. So they go through a little introduction and they talk about, why is this stuff important? They tell you how to weigh your aircraft, which is something that gets rarely done for GA airplanes for the most part. They will weigh it once when it comes out of the factory, and after that you're relying on a string of A&P mechanics to correctly calculate the new weight and balance. Other things they don't take into account is the fact that you will accumulate dirt over time. You might repaint the aircraft. All of these things are going to affect the weight and also the balance. So, something to keep in mind. Okay, so this first part is all about how do I reweigh my plane, which most people don't do. And then they talk about how do you load stuff. So when it comes to doing weight and balance, you have to calculate the CG position And some aircraft will have, here's the CG, and here is the moment. They have different ways of measuring this stuff. But here is how you calculate the moment. And this is very easy to remember. Your mom is warm. So moment equals weight times arm. We'll come back to that in a little bit. So here they talk about loading your aircraft. Now, they talk about the front passenger seats in the Cessna, and they say the CG position, right? Now, the CG is measured from some datum line. Now, common places that they will pick is the firewall, the spinner, some point in front of the airplane, and the leading edge of the wing. What are some advantages of things like a point in front of the airplane? Well, the biggest advantage is all the distances are positive. If I pick, let's say, the leading edge, which would be about here, some things would be positive and some things would be negative. Just makes life a little bit more complicated. Now in the Cessna, I believe they use the firewall, and the front seats are adjustable, so they can be between 34 to 46 inches from the firewall. And they said 37 is pretty typical. Sometimes, though, you want to know a little bit more exactly. Like I used to have some friends, and they had a beach sundowner. And you can always tell the sundowner pilots because they did a weight and balance before every flight, because that CG range in that plane is very, very small. Well, I had a general manager for my flight school down in Georgia, and he was about 350 pounds, 6'6". And when he would sit in any seat, it would definitely be at the rearmost position. And he's a big guy, so you would want to calculate using that, not using this average. The rear seat is fixed, 73. Then we have the first baggage area at 95 and the second at 123. And there's a little note here talking about, where the different dividers are in this baggage area. It's kind of an FYI. Now, you can't see it from this picture, but if you were looking at the actual aircraft, this is a raised area. And this is just down to the floor. Like everything is on the same floor here. And then it goes up a little bit, and there's a baggage area in the back where you can put like your hats or maybe a briefcase or a tow bar, things like that. And here you can see what I'm talking about. That's that cutout area. Okay, so they even tell you how big the doors are, I guess, if you're trying to get stuff in there. I've had the pleasure of trying to crawl through this little door, by the way, with a broken Cessna door latch. It's not fun. All right, so a little bit more about, cabin measurements and all of that. And then here, what do we have? We have a little bit of a table for calculating moments. So, you have your basic empty weight. They said typical 1642, but of course you need to look it up for your aircraft. Then we have fuel. Fuel weighs 6 pounds a gallon. This aircraft will take a maximum of 53 gallons. That's another thing that typically people like to do. They like to say, all right, here's how much my plane weighs and what the CG is at full fuel, and here's the same thing at empty fuel. Then we have a pilot, front seat passenger, rear passengers. Now you might say, how did they calculate all of this stuff? Well, if you look a little further down, they have tables. So this is the way that Cessna does things like this. So you've got the moment when you have the pilot and front seat passenger. So if you have a combined weight of 400 pounds, your moment is 15,000 pound-inches. If you have full fuel, that moment is slightly more than 15,000. We have a rear seat passenger, baggage area 1, baggage area 2. Once you've figured this out, once you've put in all this information, you can find the moment. And here we have our envelope. Here's the weight, and here's the CG position. Or actually, in this case, it's the moment. So some airplanes in the manual will have CG here and weight here. This one has moments here and then the weight over here. So when we say you're operating outside of the envelope, here's the envelope in which you can operate. You'll notice there's a smaller envelope, and that's the utility category envelope. Well, what's that all about? In the normal category, I need to have certain G limits, plus so much, minus so much. In the utility category, I have slightly higher limits, so I can maneuver a little bit more forcefully if my aircraft falls in this category. So for example, on the Cessnas, if you wanted to do spins, normally you have to be in the utility category to perform spins. At least intentional ones. Hopefully you don't have any unintentional ones. And here we have the same thing, except for now we have CG here and we have weight here. And again, you can see, all right, here is utility and here's the normal category. Beyond this, they go into an equipment list, and they say, how much does this weigh? Where is it? And they can use that to calculate the moments. All right, so something that's very commonly done whenever you have an airplane, especially if it's your airplane that you're flying all the time, would be to create a spreadsheet, because spreadsheets are cool and everybody loves spreadsheets. So if I can find my spreadsheet here, I will show you what a cool spreadsheet looks like. Just find it real quick. I thought I had it somewhere, and we go. So here's a little weight and balance sheet that I made for our 172 Alpha. That's 7842 Tango. So if I look at this first sheet, it's very basic. I said, what's the empty weight for the plane? Well, the empty weight is 1350. And what's the moment for that plane? Well, the moment is the empty weight CG of 38.42 times this. So again, your mom is warm. Moment equals weight times arm. So then I can say, what about the pilot? So if I have a 170-pound pilot, I have a moment here. Co-pilot, let's say, is 210. And there's my moment. I can calculate rear seat passengers and then baggage. There's only one baggage area in this aircraft. It's behind the rear seats. And then I figure fuel. Now I color coded this so that only the things in this light blue color are things that you should be changing. So I said 37 gallons of fuel, which works out to 222 pounds, and the arm is 47.75, and here that gives you your moment for that, right? You add up all the moments and add up all the weights, you divide the moment by the weight, and that's where you get your CG. So my CG is 39 inches with the plane loaded. As I burn fuel, my CG moves forward to just under 38 inches. So it's going to move about an inch if you fly it to empty. And the weight's going to go down 200 pounds. So you might say, well, how does that compare? You know, what's my flight going to look like? And here what I did is I reproduced the graphic that's similar to what's in the Cessna manual we just looked at. Again, this is a slightly different model 172. And that's what's up here in gray. I just said, here's a point at a weight of 1500. The moment is 55. So 1500. I didn't go down to 0 because I thought that would just be stupid. Right, this thing would never weigh less than 1,500 pounds. So 1,500, 55, and there we go to the next point, which was in the book, 1750 and 63. And I just define these points, so that's my blue box. And then the utility category is this little part here. So it just had a couple of points to define it. And that was drawn with this orange color. And this yellow line is my flight. So I start here on the edge of the utility category. And then as I fly, I get further into it. So if you asked a question like, okay, let's assume that this Cessna is approved for spins. Could I do spins on this flight? And the answer is yes. When I was in Iowa, the university there, they had one airplane that was dedicated to spin training, and it was always less than half tanks. Because some of their instructors, especially their chief flight instructor, were pretty big guys. You know, eventually I think there was a couple of the smaller female instructors, and they became the official instructors for things like spin training, because they were the only ones that could do spin training with some of our students back there. So Okay, so this is again something that you'll probably want to make if you have an aircraft. Just to show you something a little bit more complicated. Here is the same thing, but for a Piper Lance. So it's empty weight, it's a little bit higher. And I can put in my people. I can say, all right, I've got a pilot. We'll say our pilot is 210. And our co-pilot is 160. And then I have seats in the middle. We'll just say those are going to be unoccupied. I'm going to have a rear passenger at 180. And they're going to have a friend that is 200. Now, for baggage, I have two baggage compartments. I have the forward baggage compartment and the rear baggage compartment. I could say, all right, I'm going to put 50 pounds in this one and, 50 pounds in the other one. All right, looks like, this isn't the quite finished version of this spreadsheet, but I do have a version of the spreadsheet that will actually fill in this stuff for you. So let me grab the updated version of this spreadsheet. And this is the one that does the cool stuff. So again, here we have our load limits. I can put in my pilot, passenger in the front. I can put in my rear passengers at 200, 180. I can say 50 and 50. And now if I go to my CG limits, I can see that I'm overweight. So I need to do something about that. What could I do about that? Well, what's the easiest thing to do? Don't take off with so much fuel. I got 94 gallons of fuel. Probably don't really need that much. It's easier to get rid of fuel than it is to get rid of people or make them lose weight dramatically. So, that is a little bit more about weight and balance and, some things that you probably want to end up doing. Now, of course, for your test, you might have to do some weight and balance problems. If you have an electronic calculator, like an electronic E6B, these will do weight and balance problems for you. One other thing I want to make sure I mention about weight and balance, we said if your CG is too far forward, it can make it impossible to raise the nose, which is certainly better than not being able to lower the nose, because then you could stall. Something else you should know, the more aft your CG is, the less stable the plane is, but it's also faster. You might say, why is it faster? The reason that it's faster is that in cruise flight, the tail is normally producing a downward force to keep the plane balanced. If I move that CG further back, the tail doesn't have to produce as much downward directed lift, if you will. And when you increase lift, you increase induced drag. So there is a slight drag reduction for having an aft CG. So something to keep in mind. All right, so that is pretty much weight and balance. And that brings us to the end of chapter 16. So we will see you in the next and last video. See you then.